Okay, so we're looking at page 3 from exam 2 from the spring semester. Page 3 is kind of a continuation of page 2. We're doing some more multi-step synthesis, although it's a little bit less guided this time, maybe, if you want to think about it in that way. Anyway, let's take a look at product A here, right? Product A, we're starting with an alkylated benzene derivative, and we're doing a Friedel-Crafts acylation again. So let's see, we're doing 1, 2, 3, 4 carbons. So 1, 2, 3, 4. There it is. We've got an protecting group there and an oxygen, and that's going to be a big clue for us. Okay, so there we go. We got product A. Now product A goes to product B, and product B is used in two different ways to make C, D, and E. Well, you know what? Let me go back and do a little color coding here so we're all following along. Product A goes into product B, and product B here, right? Then goes to make C and D and E here, right? And I say, hey, wait a minute. Well, how are we supposed to know what product B is, right? We could technically do anything, right? We've got a whole bunch of blanks here. Well, what I was asking you guys to do here is take a look at what's going on with the rest of this. Okay, what can we do with product B? And there's a couple of important clues that I'll kind of draw your attention to here. So product B is reacted with tosyl chloride and pyridine, and then sodium hydride and THF. Okay, and it's also reacted with PCC. Now, what you need to look at is say, well, what do tosyl chloride and pyridine and sodium hydride and PCC, right? Let's take a look at these guys right here. Immediately after we make product B, we can treat it with tosyl chloride and pyridine, or PCC. Now, both of these react with alcohols, right? Tosyl chloride and pyridine turns an alcohol into a tosylate group, and PCC oxidizes an alcohol. So we know we have to have an alcohol for a reaction to happen, right? So we know that product B has to have an alcohol, but we don't have an alcohol there. What we have instead is an O-TIPS, right? So now remember in our class, what did we talk about O-TIPS, right? So that is our protecting group for an alcohol, okay? So what we need to do here to get to product B is we need to transform our TIPS there into an alcohol. So sorry about that. I'm still fighting my cold here, so I didn't want to record me coughing like crazy. So anyway, our task is to make an alcohol, and we have to get rid of our TIPS group. Now, our TIPS group, remember, is a triisopropyl silyl group, and one of silicon's best friends is fluorine, and so we need to have some kind of fluorine source there to get rid of that TIPS. The one we learned about is our tetrabutyl ammonium fluoride. So tetrabutyl NBU4 plus F minus, right? Tetrabutyl ammonium fluoride with some kind of solvent. THF is fine. But I mean, that's not too important in this case, right? We just need some kind of fluorine source. And so our product then is going to be our D-protected alcohol. There it is. Great. Now we can take that and continue on. So now we're going to take product B and react with the tosyl chloride, which means we're going to take our tosyl group, we're going to take our alcohol group and turn it into a tosylate. Remember, our tosylate is an extremely good leaving group, so we can make it leave with a nice hydride there. Right? And so if we just want to color code some things, right, we're going to end up swapping out that hydride, swapping in our hydride for that tosylate. And there we go. Fantastic. Product E then, PCC, that is one of our oxidizing agents. We don't have to worry about over-oxidation in this case because we have a secondary alcohol that we're bringing in. Right, so we're just taking a secondary alcohol into a ketone using PCC And we're good to go with that too then. So this question was, again, a multi-step synthesis, but asking you guys to kind of pay more attention to what reagents we're using along the way, right? What do these reagents act on, right? And then kind of backing out, what it is. Uh, there is a big clue there, right? If you've got a protecting group, you know that's probably going to have to come off at some point also. Um, so knowing your reagents and when to use them and how to use them is always going to be one of those key parts of organic chemistry there. Okay. All right. Last right here. One of the most important questions for all of organic chemistry, being able to draw some resonance structures. We've got this aldehyde with some double bonds along the way, and we've got a negative carbon here at the end. So let's draw some resonance structures, right? Boom, boom, right? Or we'll push our double bonds here. Let's see, we got 1, 2, 3, 4, 5, 6. Right? Right, that's our first resonance there. Drop this down, push this into a lone pair. Boom, 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 boom. All right. There's that. One, two, three, four, five, six. Whoops. Sorry about that. Got a little overzealous there with my. Well, now I'm just running out of room. Okay. Let's try this again down here. All right. So now we got our negative charge there. We got double bond, and a double bond. Okay. Cool. So there are our resonance structures for this compound. Right. Make sure to show all arrows and show all contributing resonance structures, right? So there we are, good to go. Let me zoom out here and get you guys to take a peek of what's going on. And I'll see you guys for page 4 coming up.